Dear student, now I would like to explain how to solve this problem. This problem from electromagnetic waves NCERT textbook example problem. Example problem, right? Parallel plate, a parallel plate capacitor with the circular plates of radius. Circular plates looks like this. This one also not plane, square or rectangular. Circular plates of radius 1 meter has a capacitance 1 nanofarad. Capacitance for this capacitor is 1 nanofarad. 1 into 10 power minus 19 9 farads. At time t equal to 0, it is connected for charging. It is connected for charging in series with resistor. In series with resistor R equal to 1 mega ohm across 2-volt battery. Calculate the magnetic field at point P at this point, halfway between the plates, halfway between the center, halfway between the center and periphery of the plates, halfway between the center and periphery of the plates. That means this radius of this plate is R equal to 1 meter, small r equal to 1 meter. This point P halfway between the centers, between the center between two plates and periphery of the plates, halfway between the center and periphery of the plate. This is the center, and periphery means it is edge or out of this boundary of the plate. That something that means out of the boundary between these two. The P is between these 2 points. P is these two. This is center and this is the periphery, that is edge, on the edge or out of the boundary of something, that is called periphery. So in between these two there is a point P. So from center or from periphery of the plates, it is a distance r dash, that is equal to 1 by 2 meter or 0.5 meters or 0.5 meters. At this point we have to calculate the magnetic field. So for this purpose we have to draw an ampere loop with a radius r dash equal to half meter, like this. Like this. Like this. So this point is now, it is on this loop, with a radius r dash equal to r by 2 or 0.5 meters. 0.5 meters. Now I have how to solve it. So this is the solution. So this is the capacitor, circular plates, each radius 1 meter. So area of the each circular plate of capacitor, area of between the plates, not area between the plates, area of the plates, area of the each plate, area of the each plate is A equal to 5r square, where r equal to 1 meter. So A equal to 5 meters square. 5 meters square. The electric field between The electric field between the capacitor plates at time t is given by, since at initial time t equal to 0, when the switch is closed, the bottom plate is connected to positive terminal of the battery, and hence this plate becomes a positive charge and this plate becomes a negative charge, so that the electric field between the plates directed from bottom to top, that is a positive plate to negative plate, that is given by E equal to, that is given by E equal to sigma by epsilon naught, where sigma is the charge density on each plate, that is Q of T by A. Why Q of T? There is charge is varying as the time with respect to time. Therefore E equal to, therefore E equal to Q of T by A epsilon naught, where A equal to 5, so Q of T by 5 epsilon naught. Consider an Ampere's loop. Consider an Ampere's loop. An Ampere's loop in between the capacitor plate as the point P on this loop. As the point P on this loop. Now, through this Ampere's loop, as it is enclosed some area, through this area electric field is passing from this from bottom to top, so some electric flux is passing through this Ampere's loop. Now we are going to calculate the electric flux. Now we are going to calculate electric flux that is passing through area enclosed by the Ampere's loop. Area enclosed by the Ampere's loop. E into A, E bar dot A bar dash. E, because this area is different from area of the each plate. So therefore